All right, I built this. This is out of a datasheet. I guess for a 78X datasheet. It's one of their reference circuits. It's a dual output power supply, and they got a regulator here, and like for example, 741 OpAmp, which is what I used here, and then I used a TIP 102 or no, not a TIP. I used a TIP 32 here, as my pass transistor or PNP transistor, and I pretty much, put two 10K resistors here because that's no big deal. Just tried to find a common reference point. I made no effort to tune them, so these are just like 5% tolerance, carbon film resistors. In practice, you'd put a potentiometer in here to balance your resistors, or use 1%, would probably get you close enough. And of course, I didn't use a 78X, type regulator. I used an LM317 instead, so I got a variable supply out of it. And I am, of course, coming from, my lab power supplies as the source, so I'm not too worried about, input capacitors in this situation to the regulator rather. So I didn't put the 0.33 microfarad in. Now, just quickly, here is the actual circuit that I built. So, you can see right there, there's the 317 regulator, and I had put the output capacitor, the 100 nanofarad output capacitor on it, and it come to my inputs, and then I got, like a 180 ohm resistor between the output and the adjust terminal. The adjust terminal is, on this side of this regulator. The output is in the middle, and the input is on the left. So, but at any rate, out here I got one of my 10K reference resistors coming off, and here I got the other 10K resistor, which, basically goes to the output of our pass transistor, just like you see on the diagram there. So basically, I got my 10K voltage divider instead of a 4.7K voltage divider. So those are these two resistors here, and and here's my transistor, and that's pretty much all there is to it. So I got my scope probes for analog discovery, hooked on, red probe to the yellow terminal, and blue probe to the, I mean, blue, blue probe to the negative supply, and red probe to the positive supply. So, and you can see here right now I got it set. I'm controlling it with my decade box. I got it set to minimum voltage, which is all resistors turned off. And you can see the difference is about 88 millivolts, and that's with no attempt to calibrate the two. Now, I haven't tried doing a load because I've built power supplies like this before, and usually not like this, not this exact one, because this has got a lot of flaws in it that I'll point out in a second. But still it demonstrates the principle, and it has, with no load anyway, it has pretty good, pretty good match. There'll certainly be some variation with load, but but again, I can change, the resistance values and start upping the voltage, and so that gets us up to 11 volt power supply, and that's maxed out right there. I don't think you can do better than that. But you still see, even with it maxed out, you start to see a voltage difference between the two. Obviously, you know, um, that op amp can only cope with so much. The regulator is doing better than the op amp driven part, because there's extra drops there and stuff like that that aren't accounted for. But But here, it's in this range. There's like 100 millivolts of difference. Still 100 millivolts, and that's about maxed out while it's still in control. So that's about the best voltage you can do here is about plus or minus 13, and that's with it being supplied by, plus or minus 16. But it gives you a good clue, about what this can do. So I mean, it's not a bad little deal as far as making a dual output supply. But moving back to the theory here, like I said, I built supplies like this, more complicated, but like this. Certainly, I built one based on dual, 317 regulator and a 337 for the negative, instead of using pass transistors. I've built things like that before, and even where the regulators are driving pass transistors, I built like on top and bottom. But usually, what I don't like about this kind of a thing is that your voltage range is pretty restricted, is limited by the op-amp. So, you can't get much more than a, plus or minus 15 volt supply out of it. So, usually you want more than that, like 30 or more. So, that's why it gets more complicated. The other thing to be aware of is that basically this op-amp is acting like the regulator for the negative terminal. So that means, the top terminal is a 317 regulator, so it's got its current limiting and thermal limiting and all that. Well, the bottom terminal doesn't, so you can certainly blow out your transistor if there's a short circuit to ground or to the other supply rail. So that's something to be aware of, and you'd have to put some current protection in it, at least a little, transistor with a pass element like you see in a lot of power supply designs on the internet. It has a little, current limiting resistor that ends up drawing current away from your base, if the current exceeds 0.6 volts across its emitter, base emitter junction. So you would need something like that in there, if nothing else, as an absolute limit. But it's hard to make a power supply like this with a variable current source, which is what I also did on all mine. So again, they get way more complicated when you try to do things like that. But still, I've done it with complete, transistors on top and bottom, and I've done it with regulators on top and bottom, 317s and 337s. So, but again, they're complicated. I mean, I've got lots of examples of designs I could show you if I could locate them, but I mean, I can, but I think I've gone through some of those before on other videos, so I'm not going to bore you with that here, but I'm just saying it can be done. And but it's just, that's a big, like red flag, if you're going to use this as a, your own personal little lab supply, is that you got to make sure you at least current limit the output. And two, sometimes these things can behave a little squirrely when it comes to, like, oscillations depending on your load and stuff. So you'll have to build one, on the bench and test it for your purposes, just to make sure it works the way it should. Try like charging a capacitor up with it and some stuff like that. At any rate, that, pretty much, I think, covers the topic. I did want to say, if you remember from a previous video, I did do a circuit like this a little while ago, that I built a couple of years ago on a circuit board, but it was based on a kind of a flawed design. It was, it was out of Hazen's textbook, and I always thought it looked a little dodgy because of how he did it. But at any rate, right after I made that video, I ended up blowing the op-amp out by just trying to charge like a 4700 microfarad capacitor across both output terminals, from the positive terminal to the negative terminal. Yeah, it ended up blowing out the op-amp. So, the thing just wouldn't work properly after that. Transistors were fine, but the op-amp, it was cooked. But it kind of doesn't surprise me because of how that was rigged up. I mean, it was a real squirrely situation where, instead of the op-amp, you could get it was wired that way so you can get higher voltage out of it, I think. But the thing about it is that the op amp, instead of being powered like this one is here, on the diagram, instead of it being powered like this, it was actually powered from the ground terminal, but yet it's still a ground referenced op amp. So it was a 741, but he had the positive terminal of it powered to ground and the negative terminal just like you see it here. So again, chances are pretty good that when I charged that capacitor up, one side was slower than the other, and it actually probably brought this output above the ground level, and probably and probably fried the frickin' thing, because the output was actually, its voltage was too high, and it was more than it could respond to because of that ground reference terminal. So I just think that's what fucked it up, is the voltage being momentarily too high, and it fried the thing. That probably wouldn't happen with this one, but anyway, I just wanted to, basically point that out, that, if you're going to build something like this, so test it, and, with the kind of load you're expecting to, put on it, including in ways you don't think, like putting a big ass capacitor across both output terminals and see if it blows shit up. Because it shouldn't, in fact, I guess I can go ahead and try it. It'll just cost me an op amp and a regulator, and probably won't cost me a transistor. The whole thing's current limited though. So, but yeah, I don't know what it would do. Let's see. Well, I can. Let's see. Yeah, I thought I had a bigger capacitor lying around here, but yeah, that's not very big. 1,000 microfarad. Okay, so I'm gonna basically hook 1,000 microfarad capacitor across this. Again, this isn't as big as the one I hooked to the other one, but you can, god damn it, you can kind of see what the terminals will do. Really, and you can hardly see that shit. Okay, I had to blur it so you can kind of see the color of the traces. Okay, so let's see. That's the positive terminal. Make sure this is in voltage. Yeah, let's see, 25 volts. 25 volt capacitor. I got it set to 16 volts should be fine. Okay, here we go. Yep, handle it just fine. It charged up really quick too. Yep, heard a spark when I shorted the leads. So anyway, yeah, that worked pretty well. Damn it, the terminal came loose. Okay. Anyway, covers that. So cheers.